there, folks. This video is going to be about spatial mathematics. Now that means that we're dealing with shapes and we're dealing with lines, and we will also be dealing with different views. Now, spatial mathematics, we can go on for a really long time. There are lots of different aspects of spatial mathematics that we can talk about, but I'm just going to narrow it down to just a few. So, let's first start with naming polygons. So we probably know what this shape is right here. It's a triangle. Triangles always have three sides, and this is regular because all the sides are the same. This right here is a square. Yes, you definitely named that very well. However, there's kind of a more fancy or more general name, because what happens if you have a four-sided object that looks like this? That's not a square. It's not a regular polygon. It's called a quadrilateral. This has 5 sides. This is a regular pentagon. A regular 6-sided object with all equal sides here in this case. Some of you might recognize this language, hexagon. Sometimes our tools are hex. This one right here is 7, and we call it as a heptagon. I've also seen it as a septagon, okay, but for this one we'll stick with heptagon. 8, just like an octopus, is an octagon. 9. Now there's a really great song that's going to pop up right now, or at least a link to it if you guys want to watch it. This one is called a nonagon. And this last one, 10, just like 10 in French is 10, it's a decagon. So if it is a regular polygon, it means that all sides and interior angles are equal. Now I'm just going to pull up this search right here. This is from a website called skillsyouneed.com, and it's specifically focusing on polygons. Now, I like this because there's a lot of colors and it's really nicely laid out. On this top one, you have regular polygons. That means that this angle and this angle and this angle are all equal, and the sides are equal. So all sides are equal in length and all internal angles are also equal. This is a quadrilateral. This specific one is a square. This one right here is a pentagon, a hexagon, a heptagon, and an octagon. However, there are irregular polygons. Here's an example of an irregular polygon. So that's any polygon that's not regular. So this right here, it does have 3 sides and it does have 3 angles. However, all these angles are not the same. Just like quadrilaterals, there are 4 sides, so that means it's a quadrilateral, but the angles are not all the same. And that's the same thing with this. We can get even more deep into polygons. There's a whole field of studying polygons if you are interested. Polygons, concave polygons, okay, so it has kind of like something that's cut out of it. Convex means that no internal angles are greater than 180, so all the sides pop out. And complex polygons, so that have a line that crosses another line. Normal polygon rules may not apply. So this one right here, this line goes over this way. So this is a complex one. Probably a helpful thing is these examples are not polygons, so this is a circle, it's not a polygon. Any shape that includes a curve is also not a polygon. Any shape that isn't closed, so see how there's a gap here? This can't be a polygon because it's not an enclosed shape. And any 3-dimensional objects are also not polygons. So we also talk about the nets of 3-dimensional figures. So a net is a 2-dimensional representation of a 3-dimensional object. We assume that the 3D shape is hollow and it's been flattened. So which net will make this figure So what I mean by that is maybe if we start over here, I know that I have a shape of a triangle, okay, that's attached to a rectangle. So a shape that's a triangle that's attached to a rectangle that has another triangle on this back here. And I have 1, 2, 3 sides. So I have one side, two sides, three sides. Now I'm never going to get you to draw a net, but I'm going to get you to identify which shape creates will make a net for the three-dimensional figure. So what if I would fold these flaps up, and I would fold this here and put them and attach them along these sides, then we would get this figure. Now this one's a little bit tougher. Now the two shapes that I see here is I see this circle, and I also see this right here, which is created by a circle with a chunk taken out of it, kind of like that. So if I were to cut this out, fold this so that fold this shape here so that this point is brought up and these two are attached, that creates that kind of coney shape, and then it would go all along the bottom of this. So sometimes you're going to get questions on different views. So this is just a lesson in attention to detail, really. If you look at this object from the top, what will you see? Well, if I'm looking at the top, 1, 2, 3, 4, 5, by 1, 2, 3. So which view am I getting from the top? Well, I know the one with 3 across, so this is the one. The mistakes with this one are generally that people are just a little bit sloppy in their counting, and it's easy to see between 2 and 3, but when it's like 6 or 7, it's a little bit easier just to look at it and see. Now this one right here is a little bit more complex. If you look at this object from the side, what will you see? And thank goodness they drew this little guy so that we know what side we're talking about, because of course there are lots of sides. So if I were just to be looking straight on to here, I would notice that I have 2 blocks, and attached to the 2 blocks I have 4 blocks. So I know that it's going to be this one. If it were this one, I would have to eliminate this block here. And then this would be the view. But since we have this block here, 1, 2, that matches with this one, 1, 2. And last but not least, we have a few important pieces of vocabulary. So I'm not going to exactly define these, but what I am going to do is I'm going to say a line is one-dimensional. Okay, it goes from one point to another point. A plane is two-dimensional. So it's like it has 4 points. Okay, so a plane is like a whole side of a shape. So parallel lines are lines that never intersect. Parallel lines or planes never intersect. So if the lines are parallel, there are no letters that are the same in the notation. So for example, if I look at this one, I notice this one right here, I have an F and an F. That means that F, FJ, and EF intersect at a point. Now parallel lines never intersect. So I know that this cannot be my pair of parallel lines. What about this one? I can just look at it and not even test it out and know that these are not parallel lines because they share a similar letter. That's where they intersect. Now this one right here, G, K, and D, E, and we have H, I, and D, E. Now these ones we can check because they don't have any letters in common. So G, K would be here, and D, E would be here. Now parallel lines, even though these lines would never intersect, they're not going in the same direction. So another important note here is parallel lines go in the same direction. So I know that these are not parallel because they're not going in the same direction. This one, DE, goes straight across like this, and GK go up and down. So last but not least, let's test this one out. HI and DE. Yes, these two are going in the same direction. So this is our combo. Intersecting lines or planes, intersecting are lines or planes that touch in at least one point. In lines, there are always letters that are the same. So when I look at this one right here, I say LO and MN. I can say that those are not going to be intersecting because they do not share a letter in their naming. LMNO, nope. LNNO. Hey, this one we should check out. LNMO, so we can cross this one out too. So it's just the opposite of parallel, actually. So let me just double check this. LN is here, right like that, and NO is here. Yes. See, these 2 points intersect right here at N, where the letter is common. So this is our answer. So if it is asking for perpendicular, those are lines or planes that are at 90 degrees to each other. These will also intersect. So if we have something that looks like this. How are my drawing skills, folks? Don't answer that. There you go. So this line right here is perpendicular to this line right here. I'm just going to highlight that so you can see that this line right here is perpendicular to this line right here. Or if we wanted to do a plane, a whole plane, this plane right here is perpendicular to this plane right here because they are at a 90 degree to each other. Let's just do one more example with the planes because planes are a little bit more difficult to see. So in the cube shown below, which planes intersect? So let's check this first one. BCF. BCF. So we have this front, okay? And FGH. FGH. Hey! These guys intersect at this line. So without even having to check any other ones, this is the one. Now I'm just going to check some of these other ones here just to show what I mean by not intersecting. So FGH, FGH, so this top one up here. And BCD, BCD. This is bottom one right here. These guys do not intersect because they don't touch. Alright, so the Math IXL that I want you guys to work on here, I'm just going to say Math IXL. The ones that I want you to work on here are going to be grade 8, well, T1, grade 8, T2, and grade 8, T3. And when you're ready, we can redo that portion of the diagnostic.